When you think about the dangers of space, you probably picture things like radiation, vacuum exposure, or maybe massive temperature swings. But one of the biggest threats to astronauts on the moon is dust. Not just any dust, lunar dust. It's microscopic, it's razor sharp, and it's been called the #1 challenge for future moon missions. So, what makes moon dust so dangerous, and why are scientists racing to stop it from ruining our next giant leap? Let's break it down. Before we do though, if you love science that sounds like science fiction, real geology, real space, and real danger, hit subscribe. I post weekly geology bites you won't find in your textbook. Now, lunar dust, or regolith, is the fine powder that covers the entire surface of the moon, but it's nothing like the dust you find on Earth. Because there's no wind, no water, no atmosphere, there's nothing to weather or smooth these particles. Instead, micrometeorites are constantly bombarding the surface, shattering rock into jagged, glassy fragments. Under a microscope, lunar dust looks like tiny blades, shards of glass and rock, and it's electrostatically charged from solar radiation, which means it literally clings to everything. During the Apollo missions, lunar dust was a constant headache. It stuck to everything: spacesuits, tools, the lander's interior. The astronauts reported that it scratched visors and instrument covers, damaged seals and joints, it even made breathing difficult inside the cabin, and it had a weird smell, like gunpowder. Astronauts have even developed lunar hay fever, a sneezing fit from exposure to dust inside lunar modules. Once it's in, it's almost impossible to get out. So, what's the actual danger here? Aside from mechanical wear, where the abrasive particles erode seals, jam hinges, and shorten the lifespan of gear, there's static charge, which is where the dust clings electrostatically to surfaces, resisting brushes or shakes. And that leads to inhalation hazard. These particles are so fine and so sharp, they can lodge deep in the lungs. NASA compares it to breathing in asbestos. And while we don't absolutely know the consequences of long-term exposure, it could lead to lung scarring, inflammation, or even cancer. For future moon missions, especially if we're building habitats, controlling this dust is critical for keeping astronauts healthy and systems running. NASA and other space agencies are actively working on solutions to the lunar dust problem. Some ideas they've had include electrostatic wands or coatings that repel dust using electric fields, magnetic filters for air systems, sealed suit ports that allow astronauts to enter habitats without dragging the dust inside, advanced materials that resist abrasion and dust adhesion, and there's even research into building structures underground or using the regolith itself to 3D print habitats, limiting exposure. With the Artemis program aiming to return humans to the moon and stay there, dust isn't just a nuisance, it's a serious engineering and medical challenge. Imagine living on the moon for weeks or months, and every time you leave the habitat, you bring back a microscopic threat that scratches, clogs, and could even suffocate you. If we don't solve this lunar dust problem, long-term missions might fail. Not because of big explosions or space monsters, but because of this powder. Lunar dust may look soft and harmless, but it's one of the harshest substances in the solar system. Next time you see an astronaut hopping on the moon, know that they're battling with millions of glassy particles underfoot. If you like this breakdown, give it a thumbs up and subscribe for more Earth and space geology every week. Got a weird rock or space question? Drop it in the comments. I might feature it in an upcoming video.